Hi, I'm Darren and welcome to Level Up EE Lab. In today's episode, I'll be finishing the alignment and checkout of my SX-140 amateur radio receiver. I'll follow the steps in the manual and finish the alignment, find a way to solve my missing crystal problem, and do some basic measurements of its sensitivity. In the prior two episodes for this receiver, I completed the diagnostics and repairs and only showed a very short demo of it working. So if you haven't watched those two videos yet, I recommend you do so this one will make more sense. I also said in the prior episode that I was short the 3.5 megahertz crystal to do the calibration work, and I have found a way to solve that problem. But before I get into that, let's first look at how you do the IF and oscillator alignments. Alright, I'm ready to do the alignment of the SX-140, and the first step in the process is to do the IF alignment, and I'm following the procedure that's in the manual. I did, however, decide to go a bit old school here with my choice of equipment to use for the alignment, and by that I mean I've got my Knight KG650 signal generator here, RF signal generator, and my lovely Heathkit 011 oscilloscope. Now both of these guys are Hamfest or eBay rescues that I've done where I've done the restoration work on them. In the case of the oscilloscope, I did quite a bit of work to get it back to normal operation, but I thought I'd use these to show that you can use old equipment like this to calibrate an old receiver. So modern equipment certainly can work just fine, but you really don't need it. This level of accuracy and precision equipment will work just fine. With one little caveat, I did get my digital frequency counter out and connected it to the Knight because this front panel dial really isn't super accurate. It doesn't need to be accurate to the single digit hertz here, but I still like to double check my instrumentation. It's always a smart thing to do when you're doing calibration is to cross check your readings amongst instruments and see that you're getting something you can trust. So I will disconnect the frequency counter. I'm not going to need that for the rest of the experiment, but I did want to show that it is working, and it is an odd IF frequency for this SX-140. It's 1650 megahertz or 1.65 megahertz, I should say, 1650 kilohertz. And that's a bit unusual because most IF frequencies tend to cluster around 455 kilohertz or 10.7 megahertz for higher IF. So this one's a little unique, but nonetheless, just set the signal generator per the manual instructions to 1650. And what I'll do next here, I'll disconnect the frequency counter because I do have to set the output of this guy fairly high for this guy to read it, and it's too much. It overdrives the IF section of the SX-140 if I leave it that high. So I'll reconnect the connections here, get rid of this guy, and we'll be ready to go. All right, I removed the frequency counter, and I did have to reconfigure the input to the radio slightly. The output from this Knight is still pretty high, even on the very lowest settings. So in addition to using the 0.02 microfarad cap to couple the signal into the oscillator grid, it's pin number 2 of vacuum tube number 2. So we're injecting this signal directly into the grid of the mixer tube. It's still too strong, so I put a 50K pot here in series with that signal to dial it down even further. What we're going to be doing here, as soon as I switch this modulation on here, we're going to hear approximately 400 hertz tone coming through the radio, and it's going to get pretty loud. So it's going to be, as I go through the adjustment of the IF, what you're doing, and it's very common on all these radios, you're just trying to peak the volume of the signal going through without overdriving the audio. So it'll be back and forth with adjusting the IF transformer cans and dialing down the volume and then watching the scope. The whole purpose for the scope is to give us a visual indicator. So we're not just relying on our ears. We can actually see a better qualitative indicator of when we reach the peaks on the scope. Now the procedure says to use an actual power meter, which you can do that too. And in both cases, either the scope or the power meter, you connect it across the speaker terminals and you're just getting an indication of how much power is coming through the entire audio chain. So using a non-conducting tool rather, I'll be adjusting the 4 cans, and the instructions give a specific sequence which I'll be following. There's 2 IF cans, T2 and T3, and the order is to adjust the top of T3 first, the bottom of T3 second, the top of T2 third, and the bottom of T2 fourth, and then repeat that a couple of times until you've got the true peak. Again, nothing unique here with this SX-140. It's a very common procedure to adjust the IF section in most receivers, so I'll be doing that next. But before I actually put my hands near and start touching the powered up rig, it's time for a word from Captain Obvious.
This item contains hazardous voltage and safety precautions must be followed. If you're following along and working on your own version, you're doing so at your own risk.
Okay, I'll turn on the modulation. And there's that 400 hertz tone. So I'm going to start with it tolerably loud right there and begin the adjustment. And remember, it's T3 top. So that one was pretty close already. You give it a little more gain there. Now it's T3 bottom. Okay. Third is T2 top. Okay, and then T2 bottom. Okay. So it wasn't that far out, and honestly I didn't think it would be, because on the trials I did in my last video, it sounded quite strong when I was listening to the CW and single sideband signals on 40 meters. So what I'll do off camera is just do another quick fine adjustment here, but the same procedure, 1, 2, 3, 4 through each of the IF cans, and then the adjustment of the IF stage will be complete. The next step in the alignment is to do the RF alignment, or the oscillator alignment, for each of the bands. And again, following the procedure in the manual, I still have the signal generator and oscilloscope connected from the IF alignment, but the differences are now the output of the signal generator is connected through a 27 ohm resistor to the antenna input, and we're going to go through each of the 6 band settings, different frequencies. So for example, I'm starting at 80 meters per the manual instructions, and the signal generator is at 3.5 megahertz. That's the lower end of the 80 meter band. The dial is set down at 3.5 megahertz. And off screen I did use my frequency counter again, just to make sure that the output of the night was right where it should be. And the rest of the procedure is almost identical. We're going to turn on the modulation, and we're going to listen to the tone here, and also look at the profile on the scope and tune. There's only one coil. There's a adjustable inductor to tune the oscillator for each of the 6 bands, and dial that in for maximum audio and for maximum signal. So I'll go ahead and do that now. Turn up the brightness here so we can see that a little bit better, and again using a non-conductive tool. And that's it. So 80 meters is now set correctly. Off camera, I will do the other 5 bands. It's the same procedure, just different frequencies, and setting the radio to the appropriate band for each one. So that's all there is to it, to do an alignment on the SX-140 and get it tuned for maximum performance. So the next problem to solve is that missing crystal, and here's how I solved it. The chassis has this socket right here for the calibration crystal. It uses the FT243 style case, which is very common for that era. I have several dozens of these style crystals that I saved from my dad's collection, but like I said earlier, I don't have one for 3.5 megahertz. What I do have is this 14.286 megahertz one that my dad labeled as no good. I tested it on my crystal tester and sure enough it doesn't work. So I'm going to salvage the case to hold this smaller color burst crystal inside it. Getting it open is easy. There's 3 screws that hold the metal lid to the Bakelite case, and inside there's a gasket to seal the cover to the body, and then a stack of compressed parts that hold the quartz chip. Of course, the compression spring was to go flying across the room. Pretty cool to see the construction and how these bits and pieces went together. I've heard it's possible to fine-tune these by sanding down the quartz chip if you're careful. Anyway, what I need is the empty case, and desoldering the copper leads was easy. But the aperture is too small. I'll need to modify the screw boss on the right to get more space. And after a few minutes of work on my mini mill, problem solved. Bakelite machines easily. Now my substitute crystal drops right in, and all that I need to do is insert some 20 gauge stranded wire in the hollow pins and solder it to the inside of the pins and solder it to the leads on the crystal. Here it is after soldering. Getting soldered down to the hollow pins wasn't too hard, and all that remains is to reinstall the gasket and the cover. Time to see if it works. This is the crystal tester that I mentioned earlier. I hacked it together years ago from a design in the ARRL handbook. It uses 2 transistors and a handful of popcorn parts. The socket on it is for a different size crystal though, so I have to press and hold this FT243 one in place to get it to oscillate. And judging by the readout on the frequency counter, I'd say it's working. It's a little bit off the color burst frequency, but no worries, it's plenty close enough to use for calibrating this receiver. But since it's not exactly on 3.5 megahertz, I have to make up a custom calibration table, and here it is. The oscillator in the SX-140 puts out lots of harmonics, and it's those harmonics that I'll be using, from the second harmonic for the 40 meter band, all the way up to the 14th harmonic for the 6 meter band. I love it when I can salvage otherwise junk parts and repurpose them to new uses. Okay, I'm back in the lab, and amongst all the clicking and popping of the ductwork, since it's heating season, I'll try to get in a few more minutes of video here to show what I've done. So clearly I put the chassis back in the case. I do have that calibration crystal installed. I just wanted to show real quick just how ridiculously touchy the whole receiver is to use that crystal. And then the second thing I'm going to do, I got my HP signal generator set up. I used it to do another test here for sensitivity, and I want to show those results as well. So per the manual, I'm going to do the procedure for setting the calibration of the dial pointer, and that's this control right here for cal reset. But as I said, it's incredibly touchy, so I don't know how practical this would be in trying to use it in operating conditions where you're trying to bounce it back and forth between bands. But nevertheless, the way it works is you flip the switch here from off to cal, and that engages the calibration oscillator circuit. But then it's this dance between an incredibly touchy cal reset control. Remember, this has a variable cap on it. It's almost the same size. In fact, it may even be identical to the size cap that's used for the main tuning. But it's very unusual. Typical older receivers, this size cap would be much smaller. It really would be fine tuning. But this is really coarse. So turning this on, now that you can hear the signal coming through, and I do have the pointer set at 7.16. That's right where the second harmonic is for the 40 meter crystal. But good luck trying to find that. I'm barely turning that control and losing the signal or catching the signal. And then also, too, there's this narrow range. Very narrow range I found for the RF gain. And you barely have to have the BFO oscillating. So point being, it seems like it'd be a very arduous procedure to try to set the calibration each time. All right, and the second thing I want to show here real quick is I did do some sensitivity measurements, like I said, and I used the signal generator. I do have it set for the same frequency, 7.16, just to keep from having to readjust the radio. What I'm doing here, it's very crude, since I can precisely adjust the attenuation of the output of the signal generator. I'm just going 1 dBm or dB at a time, basically, until I can barely hear the signal coming through the speaker. Now, in a lab, that would be a much more scientific measurement to do sensitivity, but nonetheless, you can at least tell A, rough threshold of how sensitive the receiver is, and B, if there's any gross differences in sensitivity between bands. So the way I did it, I'll just turn the generator on. You can hear a signal coming through, minus 97 dBm is what it's set to. And one more thing I would say before I go any further, I do have this coupled to the antenna input with a blocking capacitor, just so I'm not trying to couple any DC between the two. So just very, very simple coupling between the signal generator and the receiver. And as I start running this down, turn up the volume, I can still hear it. And I can actually run this all the way down to almost minus 130 dBm is what I noticed in my measurements with my sensitive ear. So I won't repeat it down to the nth degree here, but what I did, just made a quick note of the values that I saw. So looking at all 6 frequency bands, it was running right around, and I'm not sure this is coming through on camera. Let me double check here. Yeah, make this maybe a little closer. There, that's on autofocus now, we can see it better. So everything checked at least 120 or minus 120 dBm or better, except for 6 meters, that was off by a little bit. And just for reference, a modern receiver like my FT450D has a spec of 1/4 of a microvolt sensitivity, and that's approximately negative 120 dBm. Again, just a very basic measure I'm doing here, not a laboratory standard by any means, but certainly in the ballpark. So this guy actually is receiving pretty well. The only thing I would say about reception in general, and that's selectivity. This adjustment on the BFO is so sensitive, and of course I'm trying to judge sensitivity by, selectivity by modern standards, and that's not fair. There just isn't any signal processing sophistication whatsoever in here to compare to any receiver that's got good selectivity. But nonetheless, it's working, and I've completed all of the electrical and mechanical repairs that I need to do to this guy to get it working. There's one last thing on the to-do list, and that's to paint the case. And if you recall from some of my prior episodes on my channel, I have the HT40 matching transmitter, and its case is in much worse shape, so it definitely has to get painted. And logically, if I'm going to paint it, I'm going to paint the SX-140 at the same time to get a good color match. The problem is it's now December, and there's no way I want to be out in my garage doing spray painting in the cold, so just going to have to wait till springtime to do that. But there's certainly no reason I can't put these bad boys on the air over the next few months in the winter and just have some fun with basic receiver, basic transmitter QSOs. So look for me. I might be out there sometime in the next few months. So I hope you enjoyed this series of videos. If you did, you know the request. Please hit that like button or subscribe. And I'll say goodbye until next time. And one last thing, I will close this episode with just a minute or so of quiet, soothing CW music. Bye for now.
Mm-hmm.